In this video, we begin Unit 7, where our focus will be on hypothesis testing for one population parameter. In particular, we define a particular population of interest, and we're interested in a characteristic or parameter of that population. The one we will focus on in Unit 7 is the population proportion. So to get started, we note that to begin with, hypothesis testing is a procedure or a sequence of steps that uses sample data, facts, or evidence and probability in conjunction in order to test claims that are made about a particular population. Say, for instance, if we said, what is the average age that a woman has a baby at birth? Or what is the average age at which a woman conceives a first baby? Population of interest will be all women who conceive of a baby. And our interest is regarding that population, what is the average age at which that group conceives the first baby? Well, another example would be what is the proportion of Toyota cars that are currently at the mechanics workshop? The population in that case will be all Toyota cars, and the parameter or proportion of interest will be the fraction or proportion of all such Toyota cars currently at the mechanics workshop. So, in order to test any such hypothesis that made about any of these population characteristics or parameters, we require a statistical inferential technique called hypothesis testing. The very first step in the sequence of procedures associated with hypothesis testing is determining the null and the alternative hypothesis. The null hypothesis is written as or denoted as H for hypothesis, and then the null will be a subscript 0, whereas the alternative is denoted as H for hypothesis and subscript A or H subscript lowercase a or H with subscript 1. Any of these symbols or notations can be used to represent the alternative hypothesis, whereas H naught will represent the null hypothesis. All right, how do we set up the null and the alternative hypothesis? Let's take an example. In a clinical trial, 26 out of 852 patients taking a prescription drug daily complained of flu-like symptoms. Suppose that it is known that 2.8% of patients taking competing drugs complain of flu-like symptoms. As far as the scenario is concerned, what is the parameter of interest? What we are looking for here is a population of interest, and regarding that population, a particular characteristic that is also of interest. You might agree with me that we're interested in the population of all patients who are taking prescription drug daily. Regarding that population, there is a characteristic of that population that we are interested in. In English, you say characteristic. In statistics, we say parameter. And that would be the proportion, the fraction of this population who are taking prescription drug daily and who complained of flu-like symptoms. So our parameter or characteristic of interest will be proportion. In English, you would say fraction. We would say proportion of all patients, taking prescription drugs daily, drug daily, who complained of flu-like symptoms, And rather than write so many words anytime I want to make back reference or later reference to this proportion, I can simply denote it by P. This is the proportion, the population proportion of all patients taking flu-like prescription drug daily who complained of flu-like symptoms. Now, is there sufficient evidence to conclude that the percentage of these drugs users who experience flu-like symptoms is as a side effect has changed from what it used to be? And by change, we mean we have a baseline here because we are told that suppose it is known that 2.8% of patients taking completing drugs complain of flu-like symptoms. Well, if the evidence we gathered from this data is anything to go by, does it represent a significant departure from the baseline of what used to be the status quo? Well, the status quo is very useful for setting up the null hypothesis because this question goes ahead to say that we should state the appropriate null and alternative hypothesis in the scenario. The null hypothesis is the hypothesis of no difference from what it used to be. It represents the status quo. So in this context, the null hypothesis would feature the fact that the population proportion may not have changed from what it used to be known to be, which is 2.8%. And by extension, we are pulling it or pitching it beside the alternative hypothesis, which would indicate what we would like to check. What we would like to test is to check if this percentage has changed. That is, if the proportion is no longer 2.8%, aka it might have become lower than 2.8% or even greater than 2.8%. We would like to test, we would like to pitch this claim that it is still what it used to be versus the change that it might have experienced. So, in general, the alternative hypothesis is the research or test hypothesis for which we want to see if the sample data contains evidence that we can support it or otherwise. Keep this in mind. It is the one we're trying to see if the sample data provides sufficient evidence to back it up. Here's another example. An issue that faces individuals investing for retirement is allocating assets among different investment choices. Suppose a study conducted 10 years ago showed that 65% of investors preferred stocks to real estate as an investment. In a recent random sample of 900 investors, 360 preferred real estate to stocks, which means that the remaining 540 preferred what? Stocks to real estate. All right. So, based on this description, what is the parameter of interest? In this case, it is obvious that what we have data on regarding the results of a study from 10 years ago was the percentage or proportion of investors who preferred stocks to real estate as an investment. So, in this case, the parameter or characteristic of interest will be proportion, or if you will, percentage of investors, the population of interest who preferred stocks to real estate. That was what we have data on in the past. We're going to represent that again by P, the unknown proportion. Well, we have gone out to collect data from 900 investors, And we have that 540 prefer what? Stocks to real estate. Does the findings or the evidence in this new random sample data, does it provide sufficient what evidence to allow you to conclude that the proportion of investors preferring stocks to real estate has declined, has fallen from what it used to be 10 years ago? Well, to answer this question, the first step using the methods of hypothesis testing is to determine your null hypothesis and your alternative or research hypothesis. The null hypothesis in this case must be the hypothesis of no difference from what it used to be 10 years ago. So what would that be? Well, 10 years ago, what did we know? We know that it used to be what? 65% who preferred stocks to real estate. So that means that this proportion, the parameter, the population proportion, was 65%. And we take that as the existing status quo or state of things versus the alternative that it might have declined. That is what we want to research or test. And that should go in your alternative hypothesis. So if it has declined, it means that the proportion has declined or fallen below what it used to be, 65%. At this point, it is instructive to note something. Whenever you write your null and alternative hypothesis, they must contain the same value, 2.8%, 2.8% in the first example, and in the second example, 65%, 65%. This value is known as the null value. The same goes with 2.8% here. This is also the null value in this case, in the first example. So this guy, 2.8%, this is regarded as the null value. Let us take yet another example. Nexium is a drug that can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. The manufacturer of Nexium claims that more than 94% of patients taking Nexium are healed within 8 weeks. In clinical trials, 213 of 224 patients suffering from acid reflux disease were healed after 8 weeks. Based on the scenario described here, write out both the null and alternative hypotheses below. Again, the null hypothesis should represent the claim or the results that has been pre-existing, whereas the alternative hypothesis should be a reflection of what we want to test. So we go back here and we say Nexium again is a drug that is used to receive what? To reduce acid. And the interest or the claim made by the manufacturer is that more than 94% of patients taking Nexium are healed within 8 weeks. That percentage needs to be tested in this claim. In other words, we would like to test or research if that claim is true or not, that the proportion of patients who are healed within 8 weeks is more than 94%. We would like to test that claim, if that is what they are claiming. Well, if that is true, then the null hypothesis would be the opposite, the alternative to the alternative hypothesis. That would be equal to 94%, and sometimes, or in this context, we can also write less than or equal to 94%, since the alternative hypothesis has positioned itself to test that the proportion is greater than 94%. In all of the scenarios we have considered so far, in setting up the null and the alternative hypothesis, you might notice something, that there are a number of commonalities or common threads. One is that there is a particular value of the population proportion that we are suspecting has either changed or remains as it is. In the last case here, we have what? The population proportion and we're not sure if it is still 94% or if it has increased past 94%. And to test which is which, is it the null hypothesis that is currently valid versus the alternative hypothesis? What do? We decided to wear the hat of an investigator. We went to the crime scene or to the real world, collected data from using a random sample, and we're going to see if that data from the crime scene or the real world, if it provides sufficient evidence to either reject the null hypothesis, what used to be, or to fail to reject it. That will be our ultimate goal in this topic. All right. Now that we know how to set up our null and alternative hypothesis, the next goal is to determine whether the hypothesis test that we're about to carry out to reject the null hypothesis or to fail to reject the null hypothesis is either one-tailed or two-tailed or both-tailed. To determine that, the alternative hypothesis is key or central to that process of determining whether the hypothesis test you're about to carry out is either one-tailed or two or both-tailed tests. In particular, let's consider case 1, case 2, and case 3. In case 1, what do you notice? The alternative hypothesis is the hypothesis that the population proportion might be less than 0.3. If it is lesser than 0.3, it means if it is no longer at the level of the status quo, that is, the population proportion equals 0.3, the only other direction it could go is that it could go lower than the null value. It could go lower than the null value. And if it can only go lower, that means it's going only in one direction, which is lower. This is an example of a one-tailed test. And in what direction can it go lower towards? That would be the left. So it's a one-tailed or left-tailed test based on strictly the alternative hypothesis. And it's a test about what parameter? Of course, the population proportion, which is represented as P. If you're a visual person, we anticipate that if we're talking about a left-tailed test, there will be a concentration of a measure of probability to the left. This probability has a name. This probability has a name that we'll call p-value. This is coming up. There will be a threshold value that we're also going to discuss. That is upcoming too. Let's consider case 2. In case 2, the alternative hypothesis is only saying if it is not 0.2, the only other direction it can go is in the right direction. It can be greater than 0.2. So again, this is a one-tailed test or a one-tailed right-tailed test in the forward direction about the population parameter P. I like to take this lines away. And in the right-tailed, later on, we're going to be computing a probability that would be a visual reflection of this hypothesis testing procedure in the right direction. Lastly, in case 3, we have the alternative hypothesis indicating that it might not be equal to 0.5, whereas the null hypothesis said it is 0.5. So if the null hypothesis is saying it is 0.5, the alternative is saying it is not equal to 0.5, which means it could be greater than or it could be lesser than. Do you see what I see here? This is a both or two-tailed test. So let's write that here. Both or two-tailed test. Let me write this correctly. This is tailed. There we go. About, again, the population proportion. And later on, we're going to be visually inspecting a two-tailed test that has what? Two tails. All right. With that said, we have the right foundations for learning about hypothesis testing regarding a population proportion.